Okay, writing the component representation of a vector. Here I have a 60 Newton vector. Now that's represented by the red vector here. So we're going to rewrite that as, not rewrite it, but we'll label it as the F vector, and it's equal to 60 newtons. Alright, the first thing you want to do with this is decide what direction the components are going to go. Now we know when we add vectors at the resultant, we're going to have tail, tail here, and head, head here with the components. So we start out and we'll draw here, starting tail, and we'll go the direction like this, and then we're going to go up like this. Okay? Now you could have started the other way. It doesn't really matter. If you want to start here, tail, tail, you could have gone up with the Y component and then gone over with the X component. But again, you notice here what you have is a rectangle, and this component and this component are going the same direction, the same magnitude. This component and this component are going the same direction and same magnitude. So it really doesn't matter where you start. So I'm going to just go ahead and take these off, and we'll deal with just what's drawn here. Alright, so what we want to do is we look here, and we can tell that the X is going to go negative, and we can tell the Y is going to go positive. So I'm going to label this as the FY component, and I'll label this as the FX component. I'll move that down so you can see the arrowhead here. Okay, by definition, we should know that the cosine of 40 degrees is going to equal to the adjacent side divided by the hypotenuse. So I'll make this fx, and I'm going to just leave it positive right now. I'll change it because I know it's going to go the negative direction, over 60, because 60 is my hypotenuse. Now all you have to do is use algebra, bring the 60 up to here, and we'll rewrite that, and we'll get 60 times the cosine of 40 degrees is equal to fx. We can label that with our vector too. Okay, before you do this calculation, make sure that your calculator's mode is set for degrees and not radians, because if it's set for radians, you're going to get the wrong answer. So grab the calculator, go to my mode, and it's set for degrees. I'm set. So I'm going to take 60 times the cosine of 40 degrees, and I'm going to get 45.93. So fx is equal to 45.96. Line that up a little bit better. 45.96. I'll make that negative now because I'm going back in the negative x direction. Let's label these two while we're at it, so we don't get confused. So there's the x component. Now let's go to the y, how to calculate the y. The angle here is coming off the x-axis, so we're going to say the sine of 40 degrees is equal to opposite over hypotenuse. Again, bring that up like we did before. 60 times the sine of 40 degrees is equal to Fy. We run the calculator, 60 times the sine, 40 degrees, and we're going to get 38.57. So we can say and we should put that as newtons too. I should do that too. Okay, and that's our y component. So now we'll just circle that. So that's our two answers. Now the proper way to list this vector in component form, we list the vector f. We take the equal sign. We draw parentheses like this. We lift the fx first, so we do minus 45.96. We list the units. We do a comma. We do 38.57 newtons. That's a proper way to do this, and we'll just circle that in the red. And again, that's the way to do it in component representation of a vector. Alright, this vector here, now we're coming down and we're in the third quadrant, so let's talk about how to do this. And we notice here the angle here is coming, 44 is coming off the y-axis, so let's go ahead and label these. This is y and this is x. Let's go back to block color. So now we want to do the components. So again, do the same thing, determine what direction they're going to go. I'll start out here, tail, tail. I'll do my x vector like this. I'll come straight down with my y vector. So you notice here that I'm going to have a negative. We're going to have a negative fx vector, and we're going to have a negative fy. And it's all driven by the direction. Now, you notice here that this angle is missing. Now, what you could have done here, and I'm going to recommend we just go back and we'll do it the other way. And we're going to work in this triangle here. Now, you could say this angle is nothing more than 90 minus 44, but I don't want you to have to always do that. I want you to get used to working when the angles are coming off the vertical also. So now we're going to label this as fx, and we're going to label this as fy. Okay, so now let's talk about how to get fx. Fx now is opposite to 44. So can we not say that the sine of 44 is equal to fx over the magnitude? Let me get this out. This is 60. So we can say that 60 times the sine of 44 is equal to our fx. And again, I should be more careful about those arrowheads. And when we do that, again, we get calculator. And again, make sure you've not changed the mode. Make sure your mode is in degrees. 60 times the sine of 44 is going to give me 41.68. And again, that's in newtons. Now we'll do the fy. And can we not say that the cosine of 44 is equal to fy over the resultant, or the 60 newtons? I was going to write newtons, but I'll leave that off right now. So now we'll rewrite that, and we'll say that 60 times the cosine of 44 is equal to fy vector. We'll run those. 60 times the cosine of 44 is 43.16. Again, I'm going to come back here and I'm going to change my signs. This is going to the left. This is going down. So the way I would show this, I would show my f vector, and I would equal to, I'm going to put the components. I got minus 41.68 newtons and negative 43.16 newtons. Okay, and that would be their answer to that one. And that's how you do component form. So again, just follow the steps I've shown here in this video. Is go ahead and label the direction you think the vectors are going to go. And again, it doesn't matter whether you're going to go this way, or this way, or this way, or this way. And then just work with your trig to determine what the magnitude would be of the components. And then you just write it in this form right here. Best of luck.